Alright, and we're back. Okay. Okay, we'll wait for a few more minutes here while people start to come in. So. Alright. Hopefully a few more people start coming in. Yes, that, this. Ooh. Okay, there we go. Okay. So it'll be another minute or two before we start. But how's everybody doing? Morning, Robert. How are you? I hope you're doing good. I'm doing good. Got the weekend time, right? Everybody hopefully is ready for the weekend. I know I am. Doing pretty solid. Good morning. I'll be out of town this weekend actually, so I'll be visiting a cousin down in Dallas. That's what I'm gonna be doing. So I've owed them a visit for a long time. So actually, I haven't seen him in quite a while now. So morning. How are you, Carissa? Very good. Very good. Can't complain. Doing well, doing well. Alright, let's get all this junk out of my eye. This is kind of bothering me all day if I don't. Alright. There we go. Alright, I think we're ready to go. Okay, let's do it. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, we're going to continue moving forward here from the last section that we did. Where am I going out of town to? I'm going to Dallas. I'm going to Dallas. I'm going to be flying out tomorrow to go see my cousin and his family. An overdue trip for sure. Um, just for the weekend though. Dallas is a nice place. All right, so today we're going to go ahead and restart from where we left off last time. Last time we talked about multiplication of fractions. So multiplication of fractions is, again, something that we did focus on, and we said one of the things we talked about when it came to multiplication of fraction was saying we want to focus on simplifying before dividing. Okay, so that was kind of the big thing here, was to simplify before we divide. So let's take a look here at an example problem here, and we'll see exactly what we're working with. So let's see what we get here. So let's give ourselves a friendly reminder from last time. Okay, so 5/6 times 9/10. All right, so we said last time if we're going to simplify before we multiply, we want to find a common factor between a number in the numerator and the number in the denominator, i.e., again, one number on the top, one number on the bottom, and we want to be able to divide out by the same number if those two numbers have something in common that they can divide by. So let's take a look here. Let's look at 5. Okay, let's look at 5. Does 5 have any number in the denominator that it has a common factor with? All right, 10. Good. So let's put this in a little block here. Okay, and what can we divide both 5 and 10 by? 5. Very good. That's right. So we're going to divide by 5 here on the numerator and denominator with those two numbers respectively. 5 divided by 5 is 1. 10 divided by 5 is 2. So far, so good. Okay. Now, how about 9? Does 9 have anything in common? What numbers does 9 have in common with? Has a common factor with in the denominator? All right, 6. 6 is good. So we'll circle that. And 6, that's right. So I think, Carissa, you're one step ahead. What can we divide by between 9 and 6? And the answer is indeed 3. So we have 3 in common that we can divide by from 9 and 6. So 9 divided by 3 is 3, and 6 divided by 3 is 2. So in this case here, we have 1 times 3 over 2 times 2. So that equals 3 over 4, because now we can go ahead and reduce it down. All right. And so there we go. That's our final answer, 3/4. Any questions about that? Let's try another problem now. We'll try some more examples. More examples. All right. All right. Ah. So about 7/10 times 20 over 21. Okay. Let's take a look at 7. Does 7 have any numbers in common with the denominator? Anything we can pair together? Seven and 21, that's correct. Put a little box around that. Okay. What can we divide 7 and 21 by? 7. That's correct. Let's go ahead and divide each one by 7, since that's its common factor. So this is going to be 1, and this will be 3. Good, good. All right. What else? This is 20 here, not 26. Sorry. Probably wasn't too clear. All right. How about that 20? Does it have anything in common with the number in the denominator? All right. 10 and 20 can be both divided by 10. That's correct. So put the circle around that. And that's correct. We'll divide by 10. Spot on. So we get 20 divided by 10 is 2. 10 divided by 10 is 1. So we get 1 times 2 over 1 times 3. All right. So here we're going to get 2/3 as our final answer for this. All right, questions about that? All right, let's go ahead and do another. Okay, next one. Here we go. Okay, so let's go with this one here. 2/3 times 8/15 times 3/4. All right. All right. Let's look at each one here. Let's look at 2. What's in common with 2? What's in common with 2 that we can pair off here? Two and 4, good. Put a little square around that. And we can divide each one by 2. Okay, good. So far so good. We get 2 divided by 2 here, which is 1. 4 divided by 2, which is 2. Okay, let's look at 8. What can we divide 8 by? What can we pare down with? 8 and... Does 8 have any numbers on the bottom it can pair with? Okay, very good. That's right. 8 and the 2. So I'll put a little triangle here. And again, you're just using the existing number here. That's perfectly fine. Yeah, that same 2 that you have here, yeah, we're going to pair that up. So even if you have a result of 2, you may need to use it again. That's certainly possible. We're going to divide each of these by 2 since pretty much that's the only number. So we got 2 divided by 2, which is 1, and 8 divided by 2, which is 4. Then we have this 3, and the 3 should be pretty easy because then you see you have another 3 here at the bottom. So we'll circle these 3's and we'll divide each one by 3. So we get 1 here and we get 1 here. So we have left over is 1 times 4 times 1 over 1 times 15 times 1. So we get 4 over 15 as our answer. All right. Questions about that? No? All right. Okay. Next. All right. Next, I would like you guys to try a problem. Okay, so we're going to take 2 minutes or so, and I want you to try this problem right here. So 18 over 17 times 1 over 36 times 2/3. Once you have an answer here, go ahead and type that answer out in the chat. Okay, so let's give that a go. Okay, I've got 1 over 51 from a couple of you, all right? Anybody else have a few answers here? That's fine. All right. Did you at least try, though, Carissa? That's all I care about if you tried. All right, fair enough. Okay, let's go over the problem here, and let's see what we were working with. All right, let's see what we got. We got 18 over 17 times 1 over 36 times 2 over 3. Now, admittingly, this problem is a little bit tougher. Okay, so if you didn't get it, yeah, that makes sense. This one's not so easy, but one of the things that you can see here is you can take it into, maybe a couple different ways. First of all, the fastest way to do this problem is notice that 18 and 36 have stuff to do with each other, i.e., actually that turns out to be 18 total. So if you divide by 18 here, let's just put a box around each one that is paired off here. So you'll notice here we have 18 divided by 18, which is 1, and 36 divided by 18, which is 2. And you see this 2 here, and this 2 right here. If we divide each of those by 2, we get 1 and we get 1. And so what we're left with is 1 times 1 times 1 over 17 times 1 times 3. And so we do 1 over 51, which would be the correct answer. So 1 over 51 is correct. Now, what is important here is maybe you didn't see the 18 right away, okay? That's like the fastest way to do that problem. But like I said here, where did I get the 2 and the 7? Wait, what 7 are you referring to? This is 17, if that's where you're talking about. So that comes from this 17 here. And then this is 2 divided by 2 here. So, I think maybe 2 plus 7? Oh, okay, I think, oh, right, sorry. This should be, let me rewrite this. Yeah. Sorry about that. My handwriting's atrociously terrible. Yeah, 2 divided by 2 is what should have been written there. Yeah, sorry, my bad. Yeah, no, my bad. My bad. That's me and my absolutely atrocious handwriting. Okay. Now, what you could also do for this problem here, just to kind of let you know, if you did do it in steps, you could do it this way. You could divide this by 2, okay, and you could say, all right, 18 divided by 2 is 9, 36 divided by 2 is 18, and then you could say, well, that's, you could divide this by 9. So you could go in steps too. So that's not something I really talked about too much, but yeah, you can also go in steps to get to the same result. So I just want to show off here, be like, if you didn't, if this problem was confusing, and be like, oh, I didn't know that 18 totally went into 36, that's fine. Take it one step at a time. You'll still arrive at the same result. It just may take you longer. in any case, it's just an alternate way to do the same problem. So that's really what we're after here in this particular circumstance. Okay, so we got that. All right. Okay. So the next part here, let's go ahead and talk about the next part. Okay. So the next part here talks about multiplying whole numbers. We're not going to focus on this one too much except for maybe one part here. Yep, just with whole numbers here this time. So let's go ahead and take a look here at that first one, 8 times 3/4. And what we have to do here for 8 and any whole number here is we have a rule that we're going to go ahead and use. In a sense, all we're going to do here is rewrite this problem to make it easier to go ahead and look at. And we'll use this same technique as we continue to move on with fractions. Now, what is that rule? That rule is going to be this. All whole numbers can be rewritten as, say for example 5 can be rewritten as 5/1, or any number a, any whole number a, can be rewritten as a/1. Okay, so we can certainly have that happen. That's not too much of a problem. All right, so in our case here, if I want to rewrite 8, I can rewrite that as 8/1. And then I can multiply that by 3/4. Okay. So I just wanted to point out and say, all right, what's the way you attack those problems? Just put it over 1 and then repeat the same process that we had last time. So all we do is just, we look at 8 and 4 here. This one's pretty straightforward. Divide by 4. So 8 divided by 4 is 2. 4 divided by 4 is 1. So 2 times 3/1, which equals 6/1, which equals 6. All right, so that again is another way to kind of rewrite the problem here. And this is a technique we're going to use a lot, not just for multiplication, but for other things as well. So you'll see me use this quite often with fractions because it does significantly make the problem easier. So want to be sure that you got that down. Okay. All right. Questions so far? No. Okay. All right. So the next thing we're going to talk about here is going to be the area of a rectangle. Now you've probably heard of an area of a rectangle before. This shouldn't be anything brand new. As most people know, the area of a rectangle here is length times width. Okay, so the length of the rectangle times the width of the rectangle. Okay, so what we're going to do here is we're going to do an application here of a multiplication, all right, with fractions. So let's go ahead and do an example right away, and we're going to see exactly what we get. All right, so let's look at letter B here. Find the area of this rectangular truck running board. Okay, so here we have the length here being 7/10 of a yard, and the width here being 5/14 of a yard. Okay, so can anybody tell me how can we set up this problem? What should we do? How do we find the area of this figure? 7/10 times 5/14. Okay, that's correct. So 7/10 plus times 5/14, fine. Okay, let's look at 7 here. Does 7 have anything in common? Seven and 14. Okay. So we can take out that 7 there. All right. So let's do that. Go. Okay, so we have 7 divided by 7 there. That's going to be a 1 and a 2. All right, anything else? All right, 5 and 10. So we're going to divide by, what should we divide by? All right, let's divide by 5. So here we have 5 divided by 5, which is 1. 10 divided by 5, which is 2. All right. All right, so putting that together here, we're going to have 1 times 1 over 2 times 2. So our area here for this guy is 1/4 yards squared. Okay, so another way to say yards squared is a square yard. Okay, any questions about that one? That one shouldn't be too bad. Nope. All right. Okay. Let's look at the next section here. So the next section here is talking about application problems with multiplication. So again, the the area is just one example of an application, but we have more than just that, of course. We have applications in other aspects as well. So let's take a look at some of those problems. Now, before we do, however, let's talk about some of the keywords here that we're going to look that you can see here for multiplication. Now, 3 of those keywords are ones that you've probably seen before: product, multiply, times. But there is one more keyword here in these problems that is going to be important. Okay, and we'll take a look at that here with this first example. Okay, so let's read this carefully here, and we'll look at the important keyword here. So it says, let's get example 1. Lois gives 1/10 of her income to her church. One month she earned $2,980. How much did she give to her church that month? Okay, so you see all these words here, you're like, I have to be able to interpret this. Okay, so the interpretation here is the most important thing. All right, we have to be able to interpret this appropriately. So what's the key word here in this case? So the key word here in this case, from all the other words here in this word problem, actually, surprisingly enough, is going to be the very mundane word of. Okay, so of is the most important word in this word problem. And why is that? Well, of here in mathematical language at the very least is also representative of multiplication. Okay, so when we say of, that's the key word we're looking for. Of that. So when we look at this here, of being the keyword of multiplication, it says 1/10 of her income. So if we look at it from a big picture perspective here, it would be 1/10 of multiply, so we'll put of her income. So again, 1/10 times her income. Okay. All right. So all we're going to do here in this case is we're going to take 1/10 and we're going to multiply that by 2890. Now for this particular section here, because you could end up with very, kind of messy numbers, you can go ahead and use a calculator for this, so that should be fine. So can anybody tell me what we get here for this problem? 1/10 times 2890. $289. Okay, good. So 289 is absolutely right. Okay, let's look at the next one here. Let's see, which one do I want to do? Oh yeah, we'll do this one. Okay, so let's look at this one here, letter B. So let's have you guys give it a try. Okay, letter B. A retiring firefighter will receive 5/8 of her highest annual salary as retirement income. If her highest annual salary is $62,504, how much will she receive as a retirement income? Let's go ahead and take a minute, maybe even 30 seconds. Once you have your answer there, go ahead and type that out in the chat. Okay. Again, it's okay to use your calculator for this one. Okay. All right. Let's go ahead and stop right there for just a second. All right, let's see what we get here. So again, the retiring firefighter will receive 5/8 of her highest annual salary. So we're going to take 5/8 times 62,504. All right, so that's going to be our setup there. Okay, and so if we go ahead and multiply that together, we indeed will get $39,065 as our final amount. All right. Let's take a good look at this one. Of the 39 students in Mrs. Martin's high school econ class, 2/3 plan to go to college. How many plan to go to college? So again, the wording here is slightly a bit different, but the interpretation here is exactly the same. All right, so it says of the 39 students, 2/3 of them plan to go to college. All right, so 2/3 of the 39 students. That's the way we're kind of looking at it based on the wording of the question. So what we do know is that basically this is going to be pretty similar to the last one, where we're going to have, say, 2/3, and we'll multiply that straight up by 39. Oh, sorry. my bad, I was just reading the problem there. If it makes you feel any better, my last name's super common too. All right, so the answer indeed is 26. That's right. Yeah, you can put the 39 over 1, absolutely. And if you want to reduce it down, you divide by 3 and you divide by 3. And so here you get 13. So this would be equal to 2 times 13 over 1 times 1. So just like that. Okay. Okay. Let's look at this next one here. All right. So let's read this carefully and we'll see how this goes. Okay, so in her will, a woman divides her estate into 6 equal parts. 5 of the 6 parts are given to relatives. Of the 6th part, 1/3 goes to the Salvation Army. What fraction of her total estate goes to the Salvation Army? Okay, so this one here is a little bit trickier than maybe the last two. All right, so let's see how we can interpret this problem and be able to solve it. The first thing that we have to do in order to interpret this properly is to understand this part of the sentence. Of the 6th part. What exactly does that mean? Of the 6th part. I mean, of the 6th part. That's true, that's not the part given to relatives, but how can we express that numerically? Okay. Oh, not 6 over 1, but 1 over 6 of the 6th part. So that's like 5. So if you take a look at the first part, your 5 of the 6 parts were given to relatives. So 5/6 of the estate is already given away. So we're talking about the small 1/6 portion that we have here. Okay. So we start off with 1/6. Now what do we do with that? What should we do with that 1/6? All right, multiply by 1/3. Good. So if we put that together there, Again, of the 6 parts. So of, right, times 1/3 goes to the Salvation Army. So again, our answer here will be 1/18. Okay. All right, let's take a short minute here and try this problem out. So at our college, 1/3 of the students speak a foreign language. Of those speaking a foreign language, 3/4 speak Spanish. What fraction of the students speak Spanish? All right, so we'll take 30 seconds, a minute, to have you guys give that a go. Okay. All right, so we got a 1/4 here. Let's take a look and see what we get here. So we got 1/3 of the students here. So we get 1/3 of 1/3 of the students speak a foreign language. Of those speaking a foreign language, again, it's still times, 3/4 speak Spanish. So the 3's we can divide by 3 and divide by another 3, get 1 and 1. So the answer is going to be 1/4. That's correct. All right, good. I did this the last class, but yeah, that just went over that real super quick. All right. I'll leave this example up to you at the end of the day with the circle graph stuff. You're just reading a chart here. Yeah, like the only one that really matters is probably letter B and D. So we could go ahead and quickly do those. So it says, what number of children buy food from a vending machine? Well, if you notice, the vending machine has 1/5 of the pie. So you multiply that by the number of children that they surveyed, which was 2,500. So in this case here, you would do 1/5 times 2,500. Oh, why not? So 1/5 times 2,500, which is equal to 500. So if you wanted to figure that out, take a look at the fraction, multiply it by the number of students, and then that's what you get there for your result. So there is that. All right, any questions about applications of multiplication? Okay, so far so good. All right. Okay, next. So let's talk about the next section here. The next section here is talking about dividing fractions. Okay, so dividing fractions is going to be, again, the next operator down. So let's talk about how we can look at dividing fractions here. We'll talk about the rule, and we'll take a look at a couple of examples. Okay. So the first thing is about dividing fractions is that unlike multiplication where you can multiply straight across, dividing straight across is not possible. But one thing that we do know here in regards to dividing fractions is we want to change it to multiplication. So if we change it to multiplication, it's significantly easier to do because we know the rules for fraction multiplication and reducing it down. And again, we just need to make one change in order for that to happen. So let's take a look at the rule here. The rule goes is that if we have a over b divided by c over d, regardless of whatever those numbers are, that's going to equal to a over b, so we leave the first fraction alone, change division to multiplication, and then we flip the second fraction. So the consequences, there's a consequence for changing it over to multiplication, is instead of a c over d, okay, that now becomes d over c. So you flip that second fraction around regardless of what it looks like. So as you see here, we change from division to multiplication and flip the second fraction. The flip is also called the reciprocal. So if you do hear that in the future, because I can't speak, then you'll know exactly what to do in that instance. Okay, but what we're going to do now is take a look at several example problems, and we'll see exactly how this works. Okay. Okay, we'll get to that. Which one do I do? Sure. All right, let's do that. Yeah, we're actually really close to the end of chapter 2. But chapters 2 and 3 go together, so we're going to be doing both anyway. Let's do 7/8 divided by 15 over 16. So if we take this and we say, all right, if we're dividing fractions here, we're going to multiply by the reciprocal of 15 over 16, which is 16 over 15. Okay? And now now that we have multiplication, we can repeat the process that we had in the last couple sections, multiplying those fractions together. We can divide this by 8, divide this by 8. This is, oh, that's 1. And this is 2. So here we get 7 times 2 over 15. So we get 14 over 15 here as our final answer. Questions so far? Let's take a look at another one. No? Okay. Alright, let's have you guys give this one a try. 5/9 divided by 10 over 21. Should be 21 here. Yeah, 10 over 21. So 5/9 divided by 10 over 21. I'll let you give that a try. I don't know if they did or not. I haven't checked yet.